Hey, welcome back to Minute Science Marvels, where we explore fascinating science topics in under 15 minutes. Last week, we talked about nuclear fusion and how stars create energy. This week, we're tackling black holes. These strange objects are some of the most extreme and mysterious things in the universe. We'll go over what they are, how they form, and why they're so amazing. Let's get started. So we're starting with our most important question. What are black holes? Black holes are places in space where gravity is so strong, nothing, not even light, can escape. If you've seen the short form video, excuse the repetition, but I love this analogy. Think of marbles going down a funnel. They spiral down, except they'd never come out. That's kind of what happens near a black hole, except it's light, gas, and even entire stars that get pulled in. The actual hole of the funnel is the tiny point called the singularity, where everything gets compressed into an infinitely small space. The outside of the funnel is the event horizon, the point of no return. Once something goes in the funnel or crosses the event horizon, it's pulled in and it can't get back out. Black holes come in a few different sizes. First, there are stellar black holes. These form when massive stars collapse. They're the most common type of black hole, and their size can range from 3 to 20 times the mass of our sun. Then there's supermassive black holes. Found at the center of galaxies, including our own Milky Way, these giants are millions or even billions times the mass of the sun. There's also primordial black holes. These are still hypothetical and might have formed shortly after the Big Bang. Their sizes could range from as small as an atom to as massive as a mountain. Fun fact, the nearest black hole to Earth is called Gaia BH3. It's about 1,560 light years away. A light year is the distance light travels in 1 year, which is about 6 trillion miles. So Gaia BH3 is roughly 9.4 quadrillion miles away. That might sound far, but in cosmic terms, it's relatively close. It's estimated to have a mass of about 12 times our sun, but black holes are so compact. Imagine squeezing that mass into a sphere just 15 miles across, roughly the size of a small town. That's the incredible density that black holes achieve, where something so massive is packed into such a tiny space. So, how do black holes form? Usually, they form when massive stars die. When a star runs out of its fuel, it collapses under its own gravity. If the leftover core is heavy enough, it becomes a black hole. But this isn't the only way. Some might also form directly without an explosion. Others form by merging black holes, and some might even date back to the birth of the universe, those primordial black holes that we talked about earlier. But let's talk about the typical, most common steps of black hole formation. First, we start off with a star. Once the star can no longer produce energy through fusion, it ran out of fuel. Without that outward pressure from fusion to counteract gravity, the star begins to collapse. Gravity pulls the star's core inward, compressing it into a smaller and denser state. Think of it like a balloon deflating. The outward pressure from the air inside keeps it puffed up. But when the air is gone, the balloon shrinks and it crumples inward. Similarly, when fusion stops, the star collapses under its own gravity. This process triggers a supernova explosion, where the outer layers of the stars are violently blown away. Imagine that balloon popping. The remaining material is just hurled outward in all directions. What's left behind is just the core, which continues to collapse because, again, that gravity is still there. Eventually, the core becomes a singularity, the point with no size but nearly infinite mass, and the black hole's event horizon forms around it, making that point of no return. Fun fact, when a star goes supernova, the explosion is so powerful that it briefly outshines the entire galaxy. For a few weeks, it can emit as much energy as the sun will produce over its entire 10 billion year lifespan. Some supernova can even be seen from the naked eye from Earth, like the famous SN 1987A, which was spotted in 1987 in a neighboring galaxy. Okay, what are the physics of black holes? Black holes are strange because they stretch and twist the entire fabric of space and time. Their immense gravity creates some mind-bending effects. Here are some of the key effects of black holes. These are just a few of the incredible ways that black holes shape the universe and things around them. First is space-time curvature. The mass of a black hole bends space-time, creating a well that pulls in nearby objects. Think of space-time as a trampoline. If you put a bowling ball in the center, it creates a dip, and the smaller objects nearby all roll towards it. A black hole is like placing something infinitely heavy in the center. The dip becomes so steep that nothing can escape. Another one is time dilation. Near a black hole, time slows down compared to the areas far away. Imagine standing at the edge of a fast-moving river. If you drop a leaf into the current, it slows down once you get to the whirlpool. For a black hole, this means a minute near the event horizon could equal years or even centuries for someone far away. There's also spaghettification. This one is one of my favorites just because of the name. This is a dramatic process that happens if you get too close to a black hole. The gravitational pull on the side of your body that's closer to the black hole is so much stronger than the other side that you would be stretched out like a spaghetti noodle. Imagine like when you pull taffy. One end gets pulled faster than the other, which stretches it into this long, thin strand. That's what would happen to an object falling into a black hole, just on an extreme scale. Also, we kind of mentioned singularity. At the center of the black hole is a singularity, the point where gravity becomes infinitely strong and all matter is crushed to a size smaller than an atom. Physics as we know it completely breaks down here, making it one of the greatest mysteries of science. Another one is Hawking radiation. Black holes aren't just consumers, they slowly leak energy through a process called Hawking radiation. This happens because of quantum effects near the event horizon. Over billions of years, this radiation can cause black holes to lose their mass and eventually evaporate, kind of like an ice cube. Even though it seems solid, over time it shrinks. Hawking radiation works similarly, melting down the black hole's mass away. Because of E equals mc squared, that mass has to go somewhere, so the mass of the black hole is radiation. This next one is another one that's so cool, photon spheres. Just outside the event horizon, there's a region where light itself orbits the black hole in a perfect circle. Don't make this a goal or anything, but if you could somehow stand on the side of the black hole, you could see the light bending around you, creating like a kaleidoscope effect. So those are all cool, but do we have anything recent, any new discoveries? Of course. Black holes continue to amaze scientists with new findings that push the boundaries of what we know about the universe. I picked 6 of the most exciting and the most recent discoveries, and we'll talk about them. Recently, astronomers observed an enormous gamma ray burst that was believed to have been tied to a black hole. These bursts are the brightest explosions in the universe, which release as much energy in a few seconds as the sun will produce in its entire lifetime. This discovery showed how dynamic black holes can be and provided clues about their interactions with the surrounding matter. For another one, in 2019, scientists did something huge. They captured the first black hole image. The Event Horizon Telescope captured the first ever image of a black hole in galaxy M87. The image showed the shadow of a black hole, surrounded by a glowing ring of superheated material. This landmark achievement confirmed Einstein's theory of general relativity and marked the beginning of a new era in black hole observation. In 2021, there was another groundbreaking discovery. Astronomers detected X-ray echoes from behind a black hole for the first time. The intense gravity of the black hole bent light from its far side, allowing scientists to observe an effect predicted by Einstein's theory of relativity again. This opened up a new way to study the regions that are closest to black holes. In 2015, scientists detected gravitational waves, ripples in spacetime from 2 colliding black holes. Since then, dozens of these events have been observed, including a merger between a black hole and a neutron star in 2021. These detections allow us to listen to the universe in a completely new way. In 2017, astronomers discovered black holes that grew to enormous sizes very early in the universe's history, just a few 100 million years after the Big Bang. One of these black holes has a mass of 80 million suns and raises new questions about how black holes can grow so quickly. In 2022, scientists confirmed the first ever detection of a free-floating black hole in our galaxy. These are rogue black holes, and they wander through space without a companion star or a galaxy, making them incredibly hard to find. This discovery was made using microlensing, where the black hole's gravity bent the light from a distant star. So that's all awesome, but why do black holes matter? Black holes might seem distant and unrelated to our everyday lives, but studying them has profound implications for science and technology. Here's why. They help us understand how gravity works. Black holes are natural laboratories for testing the limits of Einstein's theory of general relativity. They allow scientists to study gravity under the most extreme conditions, revealing how space-time behaves when it's stretched and warped by immense mass. Why does this matter? Understanding gravity at this level could lead us to breakthroughs in physics, which potentially helps us unify gravity with quantum mechanics, one of the biggest challenges in modern science. It also tells us how galaxies form and evolve. Supermassive black holes at the center of gravities plays a crucial role in shaping their surroundings. The energy released by materials falling into these black holes can regulate star formation and even influence the size and shape of galaxies. Without the influence of supermassive black holes, some galaxies might look very different or might not even form at all. They also tell us the connection between quantum mechanics and general relativity. Black holes are where the large, general relativity, meets the very small, quantum mechanics. The singularity at the center of the black hole represents a point where our current understanding of physics just totally breaks down. By studying black holes, scientists hope to develop a unified theory that connects these two fundamental branches of science. Why does that matter? A breakthrough in this area could unlock entirely new ways of understanding the universe, from the smallest, teeniest, tiniest particles to the largest, huge cosmic structures. There are also technical innovations that come from black hole research. The tools used to study black holes, like advanced imaging techniques, powerful microscopes, and massive data processing systems, also lead to technological advances in other fields. One example is the algorithms that are used for black hole imaging are now used to improve medical imaging techniques like MRIs. Data analysis methods for black hole research also have application in artificial intelligence, climate modeling, and financial systems. And an underrated one inspiring the next generation. Black holes capture the imagination of people of all ages. By studying and sharing the discoveries of these cosmic phenomena, scientists can inspire curiosity, drive interest in STEM fields, and encourage the next generation of explorers to push the boundaries of what we know. All right, to recap, black holes are some of the most powerful and mysterious objects in the universe. They form when massive stars collapse under their own gravity, creating a region where nothing, not even light, can escape. Near a black hole, space and time stretch in crazy ways. We've talked about time slowing down, light orbiting in photon spheres, and objects being stretched into long, thin strands, and my favorite process, spaghettification. Black holes can also play a huge role in shaping galaxies and helping us understand the universe. They've taught us about gravity, how stars and galaxies evolve, and even the strange connection between tiny particles and the largest structures of space. Recent discoveries, like seeing X-rays from behind a black hole, observing gravitational waves from collision, and capturing the first ever image of a black hole, show that we're just scratching the surface of what we can learn. Black holes might feel distant, but studying them helps us uncover the secrets of how the universe works. Thanks for tuning in to Minute Science Marvels. Don't forget to subscribe and share this episode. You can also find me on YouTube, Spotify, TikTok, Instagram, Lemonade. I think that's everything under Minute Science Marvels. Let me know your questions or thoughts in the comments, and I'll see you next week for another dive into the wonders of science.